Welcome to the MultiSTEEL 3D tutorial. This tutorial will provide an overview of how to draw and edit steel in the 3D environment using MultiSTEEL 3D. We have tailored the way we draw the steel so that we can cover the basic aspects of MultiSTEEL 3D. We will also be looking at how MultiSTEEL automatically updates the 3D model once 2D drawings are edited, along with how steel information can be exported to external design, analysis, fabrication and piping design software. This tutorial will also provide an overview of how to create stairs, ladders and handrails using the MultiSTEEL Access toolbar. Please allow at least 35 minutes for the complete tutorial. Before proceeding with this tutorial, you must have first created the 2D framing plan drawing as shown in Tutorial 1. Use the Open command to open the existing drawing. Now that we have our 2D framing plan drawing open, we can erase the material list and details, as we will just be concentrating on the frame itself. We can now move across to the MultiSTEEL toolbar and scroll along the MultiSTEEL 3D flyout until we locate the Set View icon. We can use the MultiSTEEL 3D Set View command to set the view of our framing plan to isometric. In the MultiSTEEL Set View dialog box, we will select the front right isometric view as shown, and then select OK at the bottom of the dialog box. Our framing plan is now set to isometric view, and this will allow us to easily place our 3D datum symbol on the frame. The datum symbol is used to indicate the insertion point and orientation of the 2D frame in the 3D model. To make it easier to place our datum symbol, we will change the steel representations from 2D to stick. We can move across to the MultiSTEEL editing toolbar and scroll along until we locate the Show Stick icon. When prompted to select objects, we can right mouse click or enter. This will then prompt us with the option to select all steel. We will select Yes. All of our beams are now shown in stickline representation. We will be selecting the bottom left-hand corner of our frame as the insertion point for our datum symbol. To access the datum symbol, we can move across to the MultiSTEEL toolbar and scroll along the MultiSTEEL 3D toolbar until we locate the Insert Symbol icon. When prompted for the insertion point, we will select the bottom left beam intersections on our 2D framing plan, as shown. The datum symbol can be placed on 2D drawings to represent different views in your 3D model. For our framing plan, we will select Plan View. We are now presented with the datum symbol values. The frame description can be any descriptive text that will help you identify your frame. The origin point in model will be your 3D insertion point within the 3D model. As our 2D frame is called EL5000, we will make our insertion point values as shown. To keep things simple, we will call the export file name or steel exchange file EL5000. We will call the structure record name or rec file name the same as our 2D grid name as shown. There are many other options, but we can ignore these for now and select OK at the bottom of the dialog box. Our 3D datum symbol has now been placed, and we can see the X, Y and Z directions along with our descriptive text. We can now move across to the MultiSTEEL toolbar and again access the Set View command. To set the view back to Plan View, we can select the middle of the Set View dialog box graphic to change from ISO to Plan, and then select OK at the bottom of the dialog box. Our frame is now ready to be exported. To export our 2D framing plan to our 3D model, we can move across to the MultiSTEEL toolbar and then scroll along the MultiSTEEL 3D flyout until we locate the Export Frames icon. Once we release on the icon, Our 3D datum symbol is automatically selected and we are prompted for the first corner of our frame. We can now place our selection box around our 2D framing plan as shown. Our frame has now been exported. If we press the F2 key to bring up our AutoCAD text window, we can confirm that our frame has been exported and that our record file has been updated. Let's now start a brand new drawing in AutoCAD for our 3D model. We can use the multi.dwt as we are working in metric, and then select Open. We are now presented with the multi-draft drawing setup. We can accept the default values of A1 and the border style, and then select OK. We can edit the file name to STTUT3D so that we can refer back to it later. As we will be using this drawing and its steel information, we will save the drawing as ST-TUT3D in the same location as our 2D framing plan, as shown. Before we create our 3D grid, we will again access the MultiSTEEL 3D Set View command to set our view to isometric. We can now move across to the multi-draft toolbar and scroll along the multi-draft grid flyout until we locate the 3D grid icon. We could start a brand new grid and provide X, Y and Z spacing, but as we already have a grid created, we can select the Open Grid option in the Grid Layout dialog box. We can now select the grid that we used in our 2D framing plan. We already have X and Y, or front and right spacing. In order to create our 3D grid, we will need to add elevation, or Z spacing. For this tutorial, we will leave the origin in the model, or the 3D insertion point for our grid, as shown, but this can be changed if you need your 3D model to be located in true world coordinates. The first spacing will always be 0. The elevation can be changed to set the grid above or below datum, but we will accept EL0 and then hit Enter on the keyboard to move to the next spacing. We can now repeat this and type in the spacing to each floor level as shown. Once we are happy with our elevations, we can select OK at the bottom of the dialog box. The 3D grid will be drawn, and a view will be made of each plan and elevation grid line. These views can be set using the MultiSTEEL 3D Set View command. The views are special clip views that allow only objects on the grid line or grid elevation to be displayed. To help focus our attention on the 3D model, we can erase the title block information. We can also save the drawing. Now that we have our 3D grid, we can import the 2D framing plan into our 3D model. We can move across to the MultiSTEEL toolbar and then scroll along the MultiSTEEL 3D flyout until we locate the Import Frames icon. As soon as we release on the icon, our 2D framing plan has been imported into our 3D model at the desired orientation and location. The imported framing plan has been highlighted as red so that you can identify new steel added to the 3D model. If we highlight the imported steel and then use AutoCAD to set the color to by layer, we will then see our steel as MultiSTEEL stick lines. We have seen in Tutorial 1 that steel can be shown in different representations. We will now show the imported steel as steel symbols. We can move across to the MultiSTEEL toolbar and then scroll along the MultiSTEEL editing flyout until we locate the Show Symbols icon. When prompted to select objects, we can enter or right mouse click and then select Yes when prompted to select all steel. Our imported steel is now shown as steel symbols. To prove that the steel is from our 2D framing plan, we can use the MultiSTEEL inquiry to show the steel information on any member. We can again move across to the MultiSTEEL toolbar and then scroll along the MultiSTEEL editing flyout until we locate the steel inquiry icon. When prompted to select objects, we can select an individual beam as shown. The beam information is then displayed, and we can see that the beam came from the drawing called EL5000. Once we are finished, we can select OK at the bottom of the dialog box. We can now add more steel to our 3D model at different elevations. To place steel on our top elevation, we can move across to the main MultiSTEEL toolbar and access the MultiSTEEL Set View icon. Once we release on the icon, we are presented with the MultiSTEEL Set View dialog box. To set the view to the top elevation of the grid, we can select the required elevation, then the plan image in the center of the dialog box as shown, and then select OK at the bottom of the dialog box. We can now add steel to the top elevation. We can again move across to the main MultiSTEEL toolbar and select the Draw Steel icon. In the Draw Steel dialog box, we can set the draw method to Form. Change the size as shown. We will leave the representation, justification, rotation and group as presented, and then select OK at the bottom of the dialog box. We can now select the top and bottom grid lines and all of our vertical grid lines to form them into steel. When prompted to break steel at grids, we will select No. Our selected grid lines have now been formed into steel members. We can now add steel to our base level. To set our view to our base elevation, we can again move across to the main MultiSTEEL toolbar and access the MultiSTEEL Set View icon. The MultiSTEEL Set View dialog box can also be accessed by typing SV at the command line. We will select our base elevation as shown and then select OK at the bottom of the dialog box. Our current view now displays only the objects on the plan at elevation 0. We can now add steel to the 0 elevation. We can again move across to the main MultiSTEEL toolbar and select the Draw Steel icon, or we could type in the hotkey DS at the command line as shown. In the Draw Steel dialog box, we can set the draw method to Form. We will change the section size as shown, but we will leave all the other options in the MultiSTEEL Draw Steel dialog box as presented, and then select OK at the bottom of the dialog box. We can again select the top and bottom grid lines and all of our vertical grid lines to form them into steel. When prompted to break steel at grids, we will select No. Our selected grid lines have now been formed into steel members. We will now set our view to isometric so that we can view our model. We can type SV at the command line to bring up the MultiSTEEL Set View dialog box. We can select the front right view by selecting the bottom right arrow in the center of the dialog box as shown, and then select OK. Our current view now displays an isometric view of our model. We can now easily form our vertical grid lines into columns. We can move across to the main MultiSTEEL toolbar to access the Draw Steel icon as before. In the MultiSTEEL Draw Steel dialog box, we will change the shape to UC. We can then change the size as shown. We will also change our justification from top to central and leave all of our other options as presented, and then select OK at the bottom of the dialog box. we can now select all of the top vertical grid lines and all of the bottom vertical grid lines to form them into columns, as shown. When prompted to break steel at grids, we will select No. Our selected vertical grid lines have now been formed into steel columns. We have already seen that steel can be shown in different representations using MultiSTEEL. We can now move across to the main MultiSTEEL toolbar and then scroll along the MultiSTEEL 3D toolbar until we locate the Show 3D icon. When prompted to select objects, we can select individual members. If we enter or right mouse click, we are prompted to select all steel, and we will select Yes. All of our steel is now shown as 3D. There are many additional tools that are supplied within MultiSTEEL to make use of the information that we have in our model. We will now look at how easy it is to generate the centre of gravity for our entire model. We can move across to the main MultiSTEEL toolbar and access the MultiSTEEL 3D Page 2 flyout, and then scroll along until we locate the centre of gravity icon. Once we release, we are prompted to select objects that we wish to calculate the centre of gravity of. As we wish to calculate the entire structure, we can enter or right mouse click, and when prompted to select all steel, we will select Yes. MultiSTEEL has now calculated the centre of gravity for the entire model, and the total quantity, total weight, and exact centre of gravity coordinates are displayed in the dialog box along with the time taken. If we move the dialog box, we can see a red cross placed at the centre of gravity of the model. This can be used as a last point of selection if you wish to draw a line to the point for reference or use. In addition to drawing steel members, MultiSTEEL has many access modules to assist with the generation of stairs, ladders, platforms, and handrails. We will begin by placing a stair on the model. Before we place the stair, we will show one of the steel beams as stick to make it easier to select the start point for our stair. We can move across to the main MultiSTEEL toolbar and scroll along the Edit Steel flyout until we locate the Show Stick icon. When prompted, we can select the steel beam to show as stick. We can now move up to the MultiSTEEL Access flyout toolbar and select the stair icon. In the stair dialog box there are many options. We will change the insertion point of stair to end of landing and accept the default values for the other options and then select OK at the bottom of the dialog box. We are now prompted for the end of landing insertion point and can select the midpoint of the beam that we highlighted earlier. When prompted for the overall height, we will enter or right mouse click to accept the default value presented. When prompted for the rotation, we can choose to type the value in or pick in the direction that we wish our stair to go, as shown. Our stair, along with its hand railing, is now drawn, where the number and angle of steps will be automatically calculated. The properties of the stair will be defined by the stair style configuration, which is covered in a separate tutorial. We can now choose to show our beam as 3D using the Show 3D command, as covered earlier in this tutorial. Cage ladders can be drawn by selecting start and end points or by forming existing lines into the new ladder. We will again choose to show selected beams as stick to allow us to easily select the start and end points for our ladder. We can again move across to the MultiSTEEL Access flyout toolbar and scroll along until we locate the Draw Ladder icon. There are many options to choose from in the Draw Ladder dialog box, and these are covered in depth in a separate tutorial. We will accept the default values presented and select OK at the bottom of the dialog box. When prompted for the start point of ladder, we will select the midpoint of our bottom beam as shown. When prompted for the upper landing level point of ladder, we will select the midpoint of our other beam as shown. A cage ladder and stick line will then be drawn as specified. The ladder will be drawn and stored as a block. The block name will be the same as the ladder name. The dimensions of the ladder will be as defined in the ladder style configuration, and details on this can be found in the online help or covered in a separate tutorial. We will now choose to show our beams as 3D using the Show 3D command as covered earlier in this tutorial. Handrails can be placed by picking points on the drawing or by using existing lines to form the path of the new handrails. We will change the representation of our perimeter top beams to stick so that we can use the Form command and also use the Pick Points command to place our handrail. We will use the Show Stick icon to change the representation of beams from 3D to stick. From the MultiSTEEL Edit Steel Flyout toolbar, we can scroll along until we locate the Show Stick icon. We can then select all of the top perimeter beams as shown. We can now move across to the MultiSTEEL Access Flyout toolbar and scroll along until we locate the handrail icon. In the Draw Handrail dialog box there are many options. We will accept the default values presented to draw our first handrail by using the Pick Points method and selecting OK at the bottom of the dialog box. We can then start our handrail at the first endpoint of our top perimeter beam. And then the endpoint of our other top perimeter beam, and then finish by selecting our third endpoint as shown. We can finish the command by right mouse clicking or selecting Enter on the keyboard. We can again access the handrail icon from the MultiSTEEL Access toolbar. This time in the Draw Handrail dialog box we will change the draw method from Pick Points to Form, and then select OK at the bottom of the dialog box. When prompted, we will select the two remaining top perimeter beams to form handrail as shown. We will now choose to show our top beams as 3D using the Show 3D command as before. MultiSTEEL data can be shared with external design analysis software, as well as AutoCAD and non-AutoCAD based fabrication and piping design software. You can choose to turn steel data off that you do not wish to be exported. We will turn all of our access steel off prior to exporting our steel data. We can move across to the main multi-draft toolbar and scroll along the Layers flyout until we locate the Layer Off icon. The access layers can then be selected as shown. Once we are happy with our selection, we can select OK at the bottom of the dialog box. The geometry of the structure can now be exported to an external design or frame analysis software. We can move across to the main MultiSTEEL toolbar and then scroll along the MultiSTEEL 3D Page 2 flyout until we locate the Export Link File icon. We are now presented with the MultiSTEEL Integrator Links dialog box. There are many options that we can select from. We will select the STAAD option to create an STD file ready for use with STAAD. We will accept the file name and file location as presented and select OK at the bottom of the dialog box. The export file has now been created and is ready for use. If we use the F2 key, we can see confirmation of the file creation and its location. Once the major steel has been added to the model can be broken up into separate 2D frame drawings using the MultiSTEEL 3D Model Manager. Once this has been carried out, each 2D drawing can be edited. The advantage of having separate 2D drawings is that it allows a number of users to edit and work in the 2D drawings at any one time, without being limited to just one user working on the structure. We can access the MultiSTEEL 3D Model Manager by scrolling along the MultiSTEEL 3D flyout toolbar until we locate the Model Manager icon. We are now presented with the MultiSTEEL Model Manager dialog box. We can see that EL5000 is linked to a drawing called EL5000.dwg. We will select Grid 1 Left as the slice and the 2D drawing that we wish to generate from the 3D model. Once highlighted, we can select the Section Model button. When prompted for the drawing name, we will accept the default value presented and select Save. The drawing is then created and the dialog box displays confirmation of the frame drawing and the time taken. Once we select OK on this dialog box, we are returned to our model view in isometric. Any changes made to the steel, or any additional steel added to the 2D drawings, can then be updated in the 3D model drawing as the project progresses. We will now open the 2D drawing that we just created, add some steel, and then update the 3D model with this new steel information. Select the open drawing and select the drawing just created as shown. To make the addition of new steel easier, we will change the steel representations of the columns and the first level beam to stick. We can do this using the Show Stick command as covered earlier in this tutorial. We will now draw some bracing steel for our frame. We can access the Draw Steel icon as before. We will change the section size to a CHS and the size as shown. As we are now in a 2D drawing, we will change the representation to 2D. We will also change the justification to central. When prompted to place the start point of our brace, instead of snapping to the end or midpoint of our column, we can type A at the command line as shown. We are now prompted to select a line to go along. We can now select the bottom part of our column stick line as shown. When prompted for a distance along line, we can type in 1000 at the command line. When prompted for the next point, we can select the midpoint of our first level beam. When prompted for our next point, we will type in S at the command line to start a new member of steel from the bottom of our right column. When prompted for a start point, we can again type in A at the command line as shown. We are now prompted to select a line to go along. We can now select the bottom part of our right-hand column stick line as shown. When prompted for a distance along line, we can accept the default value presented. When prompted for the next point, we can select the midpoint of our first level beam just as before. Our bracing steel has now been drawn. We can now cope the bracing steel back from the adjoining steel. We can scroll along the MultiSTEEL Edit Flyout toolbar past the Notch Steel command until we locate the Cutbacks icon. When prompted, we can select our brace members and then enter or right mouse click to finish our selection. When prompted again to select objects, we can select our first level beam and our columns. When we enter or right mouse click to finish our selection, our bracing members have been cut back from the adjoining steel members. We can then scroll along the MultiSTEEL Edit Flyout toolbar to locate the Show 2D icon to show the columns and the first level beam as 2D representation. It is good practice to name steel prior to sharing information outside the drawing where the steel has been created. As we have done previously in this tutorial, we can use the MultiSTEEL inquiry to look at any steel member's properties as shown. We can see that this steel originated in a drawing called ST-TUT3D. If we repeat this for the brace members that we have just placed, we will see that they have not been named. A quick way to name steel in MultiSTEEL is to use the MultiSTEEL audit command. We can scroll along the MultiSTEEL 3D Page 2 flyout toolbar until we locate the Audit Steel icon. When prompted to select all steel, we will select Yes. We can now see that we have two members not marked and new brace steel. We can say Yes to rename these now. In the Add Items dialog box, we will change the steel to name to unnamed and duplicate. We can accept the default values presented for the other options and select OK at the bottom of the dialog box. We can also select OK on the Audit Summary dialog box. When we now use the MultiSTEEL inquiry, we can see that the bracing steel has been named and its data is ready to be shared outside this drawing. We can now export this frame's data and also reflect this change in the 3D model. We can scroll along the MultiSTEEL 3D flyout toolbar until we locate the Export Frames icon. As soon as we release on this icon, the steel frame information has been exported. We can use the F2 key to confirm that the central record file for this project has been updated. We can now save this drawing. We can now move back to our 3D model and import the frame data to refresh the model information. We can scroll along the MultiSTEEL 3D flyout toolbar until we locate the Import Frames icon. As soon as we release on this icon, the steel frame information has been imported and the 3D model has been updated to reflect any changes to its 2D drawings. The imported steel is shown as red to highlight any new or edited steel. We can use AutoCAD to turn the color back to by layer. We can then use the Show 3D command to show all of the steel in the model as 3D. We can also double check by using the steel inquiry again to confirm that this is the steel brace that we just added to our 2D drawing. We can move across to the main multi-draft toolbar and then scroll along the Layers flyout toolbar until we locate the Layer On icon. In the Layers to Turn On dialog box, we can choose the Select All option and then OK at the bottom of the dialog box to bring back all of our access steel information. Well done! You have completed the MultiSTEEL 3D tutorial. This tutorial has given you an introduction into using some of the multi-draft, MultiSTEEL 3D and MultiSTEEL 2D commands.